And that one thing is going to be roots, square roots, and other roots. So if you've got your note packets in front of you, you can jump past that first page of just the topic outlines and kind of the goals for the chapter. And we're going to start in with 8.1 here. Let's see how much you remember, how much you know about square roots. There are important details. There are some misconceptions about these. So a square root is the inverse operation of what? Squaring, yeah, squared or squaring. There we go. So if you square something, then to undo that, you would square root the result. Do you guys know what that symbol means? Like, how would you read that? Square root of 25. And the answer to this one would be 5. That is correct. Was anyone thinking possibly negative 5?
Negative 5, yeah. Positive negative 5, right?
No. The answer is stated before is correct. The answer is stated 5. Only 5 for that expression is correct. So it comes down to meaning. Hey guys, I want to explain this. This is, I think, where confusion comes from when I try to explain this and we're just sort of chatting. This means right here has a very specific meaning. This means the, I'll put this in quotes, the principle or positive. Positive would be a synonym for principle, square root of 25. We'll get into the whole plus or minus thing a little bit later. That comes up in a certain situation. I think it's definitely overused. But what that symbol means right there is simply the positive square root of 25. And you're right. Negative 5 times negative 5 is 25. You're totally right. But that's not what the meaning of that symbol is. It's a common misconception. Thought I'd bring it up early. That's simply 5. Okay? It's what it means, right? So certain symbols mean certain things, and we want to all agree on them so that we don't have different interpretations. That is what that means. We'll get into the whole plus minus thing later, because that is a thing that does show up. And you might find that your teacher didn't mislead you. You might have just maybe twisted it a little bit, but maybe they did mislead you. Who knows? We'll see. Okay, so what are the parts of these sorts of expressions? Let's talk about that. This symbol right here, like a check mark looking symbol, do you guys know what that's called?
Square root sign?
It could, that's a specific version of it, but it has a more general word. And it's awesome. Radical, there you go. Radical. Because not every root is a square root. We're going to work with cube roots or fourth roots. There's other roots. It's not just square roots. We call this in general a radical. And then does anybody remember what we would call the inside of the radical, the number inside?
No.
It also starts with the letter R.
Rational? No.
I'll give you the first 2 letters though, like you had them R-A.
Ratio? No.
Sounds sort of like radical. No takers. Okay, it is radicand. Radicand. So the radical is the check mark looking sort of symbol indicating the root that we're trying to find, and the radicand is the expression that's been put inside that radical. Fair enough? Okay. Let's take a look here at a few more thoughts. This is where, I don't know how much you guys did in middle school. Speaking of middle school stuff, I think knowing your perfect squares up to 400 is a very handy thing. I memorized this when I was in probably 7th or 8th grade, something like that. If you know them to 12, I mean, that's pretty good. I mean, that's not bad at all, to be honest with you. Going beyond that, I think, is handy. So, there's, oops, I'm going the wrong way. How about we do this? So Christiana basically has the left 60%. Anybody have those right 2 columns memorized?
I have everything except for 17, 18, 19.
If you don't, by no means are these required for you to memorize them. I'm not going to give you a chart that just says fill these out in 20 seconds or less or anything like that. But I think that they're very useful to know. Instead of turning to the calculator, you can do it quickly and easily. And Could save you time. So just something to think about there. I thought I'd bring that up. But let's go ahead and move on from those. Use that chart as you want. So we are going to practice doing a couple of square roots here. This first one, square root of 121. What we're basically asking ourselves is, what positive number multiplies by itself to be 121? The answer is 11, yeah. So you can, if you have those perfect squares memorized, this would be where that would come into play. You can know the answer very, very quickly without even having to turn to a calculator or any other figuring out of, with some arithmetic. You can know instantly that it's 11. And then number 2, this is asking for the negative square root. Here is what we could do with this. We want to ask ourselves, 16/9 obviously, what number times itself? 3 times 3 is 9, but what times what is 16? So what would you say this would be? Negative 4/3, that's right. The opposite of 4/3, yes ma'am.
Okay, so 2 questions.
Sure.
One, why is it negative 4/3? Because when that times another like 4/3, negative 4/3 times negative 4/3 equals positive 4/3?
So what you're doing, I think what you're doing, is you are saying that this square, you're ignoring this for the moment, which is fine. You're saying that it could be plus or minus 4/3? No? We're not. That's not what we're doing. There's no plus or minus involved whatsoever here.
Okay.
And so what I would do with this is say, I realize that negative is there. We can't ignore that completely, but I'm just going to ignore it for the moment. Say, okay, what number multiplies to be by itself to be 16/9? Well, it's 4/3, but the negative was there all along, so it just gets to continue on down with the question.
And second question, why would you reduce 16/9?
To what?
3. It was 3, no 4. Can you not reduce it down to, no? Okay.
What number goes into both 9 and 16?
I was thinking 3.
3 goes into 9, but 3 does not go evenly into 16.
Oh, okay.
Now, if you could reduce it, by all means do.
Okay.
No problem. No problem at all.
That's where I missed it,
You missed what?
misunderstood my teacher last.
Oh, okay. Okay, yeah, it's possible. It happens. I'm glad you're here. Very glad you're here. Okay, so break out your calculators. Ready? Break them out. Because sometimes we will encounter radicands that are not perfect squares. The world is not filled with all perfect square numbers. In that case, the square root is irrational. A blank can be used. How about a calculator? I am old enough to where I came in right at the very end of this. We used to use charts and tables to estimate square roots. Calculators made life so much easier. You almost had to have like a week of classes to learn how to use these tables. Pain. Nowadays we just go button, 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 enter, done. It's lovely. So, square root of 11. You guys find the radical button on your calculator?
Yeah, it's the square root button.
It should be right above the squared, right?
Yeah, second square.
Second squared. Okay, so negative square root of 11. What does that come out to be on the old calculator? So negative 3.31.
Yeah.
Okay, so I did not specify, where to stop. If given a quiz or a test, I'll say round it off to the 10th place or 2 decimals or whatever, but we can just write that for the moment. And then square root of 7/5. Once again, 7/5 is not a perfect square. 16/9 was. 7/5 is not, and so we're going to maybe use the calculator here. Square root of 7/5.
1.18321.
Okay. So approximately 1.18. Of course, we're rounding those off. We're cutting them off, so they are approximately equal to. Perhaps I shouldn't be using the equal sign right there, but using the calculator is also a thing.
You should use the squiggle.
Yep, technically they should be the little squiggly. You can put a little squiggly on top too if you want. Could mean the same thing. So far so good with square roots?
Yep.
Okay, that's great. We'll practice a little bit here in just a second. Yes. So a little hint. I like this. This is a good thing to think about. A little bit of a hint about things to come for you in later years of math. We've talked about this a bit. Which of the following is a real number? And of course, if we're going to be talking about real numbers, doesn't that mean that there might be numbers that are not real?
Imaginary.
And we call them imaginary, right? So if you don't mind, set aside your calculator for just a second, and let's just think about this for a moment. Let's think about what a square root is, what it means. So take a look at A. Square root of negative 64. So, yeah, let's think. So you said 8 at first, right? So I should be able to do 8 times 8
Yeah.
and get what I had at the start, right?
It's imaginary. 8 imaginary. 8i is wrong.
It is 8i. We're not going to go there necessarily, but she's right. She's right. This is not equal to 8 because 8 times 8 is not negative 64, right? So it's not this. Some people would say negative 8. But negative 8 times negative 8 would be a positive. But that's not what a square root means. A square root means what number times itself. So the two numbers you would have to consider would have to be the exact same number with the exact same sign and everything. So this doesn't work either. And so Christiana is right. This is what we call an imaginary number. So I'm just going to for now say it's not real.
Oh, so not 8i.
Well, 8i is the correct answer. I don't want to mislead you and tell you that that's not. That is the correct answer using Euler's I notation. But for now, I think we would just say it's not real. But you have obviously learned some stuff in the past that is correct. Okay, B. What do you think of negative square root of 25? Is this real or not real?
It's real.
It is real, right? Square root of 25 is 5. The negative just makes it negative 5. Negative 5 is a real number. That is a real number. Okay, and then finally, what about C? Do you think that is a real number or not a real number?
No.
It's not a real number. So what's the pattern here? Like what are you guys seeing that causes...
In the radical.
Yes, you cannot have a negative radicand. That's it. So notice with the one that was real, the radicand was positive, and with the two that were not real, the radicand was negative. It really didn't matter what's on the outside as far as real or not real. It matters what's on the inside. If the inside is, if it's a negative radicand, it's not real. What do you think? All right. So let's do I think this is our last little section before we're going to do some practicing. There we go. Yes. Okay. There we go. Okay, so we can also have radicands. Can also have radicands that have variables in them as well. So for instance, number 6 is square root of a squared. So what expression times itself is a squared? A. A times a is a squared. And so I would just write equals a. Number 7. And the proof for this would be to say that a times a equals a squared. You're just essentially undoing your square root process. So the answer here would be a. 7, square root of x to the 6th. What do you think? What times itself is x to the 6th? X to the 3rd. Good job. And so again, kind of a check or a proof of this would be to say x to the 3rd times x to the 3rd. Whenever you are multiplying your bases, what do you do with your exponents? Add them. So x to the 3 plus 3, well, 3 plus 3 is 6. It checks. How about number 8? Square root of m to the 12th. M to the 6th. That's right. You guys notice a trend here? What is happening to the exponents on the expression every time we square root? They're being cut in half. That's a nice trend we'll talk about a little bit later. Okay, and then finally, number 9. What we have here is we've got a numerical base times a variable base. So what do you guys think this would end up being?
7r to the 8th.
7r to the 8th is definitely correct. Well done. So a check for that would be to say 7r to the 8th times 7r to the 8th. 7 times 7 is 49. And then you add your exponents. 8 plus 8 is 16. It checks with what we started off with. So square roots are basically the opposite of squaring something. Hope that you've kind of seen that coming through here. So what do you think? Do you have any questions? You ready to practice? I hope so.